If you see 1 minus cosine squared x or 1 minus sine squared x, you need to remember this identity. Sine squared x plus cosine squared x equals 1. To create 1 minus cosine squared x, I can subtract cosine squared x from both sides of this equation. So sine squared x equals 1 minus cosine squared x. So I can just change this to this. And this fraction is going to become sine squared x over sine x. You can think of sine squared x as sine x times sine x. This is staying the same in the denominator, and I can just cancel. So we're left with sine x. This is your answer. Even if you just see sine squared x by itself, still think of this identity. Sine squared x plus cosine squared x equals 1, or at least consider it. So sine squared x is going to be 1 minus cosine squared x. So I change this to this, and this fraction is going to become 1 minus cosine squared x over 1 plus cosine x. So I see 1 in cosine in the numerator and 1 in cosine in the denominator. And I also see a squared here. So if you see a perfect square here, and you see a squared here, ask yourself if you can factor out difference of squares. So this is 1 plus cosine x times 1 minus cosine x. And I just copy the denominator. Okay, so this matches with this, so I can just cancel them. And then we're left with 1 minus cosine x. This is your answer. How about this one? Yeah, you guessed it. This one's going to be sine squared theta. So it's going to be secant squared theta times sine squared theta is equal to tangent squared theta. Okay, and now we have reciprocal trig functions here. So let's see if we can express this in terms of sine and cosine. So this one, secant, is the same thing as 1 over cosine. Well, this is secant squared, so it's going to be 1 over cosine squared theta times sine squared theta is equal to tangent squared theta. Okay, and I can combine these as sine squared theta over cosine squared theta equals tangent squared theta. Sine over cosine, that's just tangent. Okay. So this is how to prove this trigonometric identity.